Dear students, Assalamu alaikum. Welcome to week 4 of our online machine learning sessions. Today we will discuss the remaining portion of our neural network lecture, and after completing this lecture of neural networks we will move on to our next algorithm. So in neural networks we were discussing about the architecture and the learning mechanism of a neural network. So we started from the very basic perceptron, and we discussed its different components, and then we move on from the single perceptron to a single layer perceptron. So we saw that there are some problems which a single perceptron is unable to resolve. So because of that we need to move from a single perceptron to a single layer perceptron in which we have multiple neurons present in layers. So in a single layer perceptron we saw that we have two layers. One is input layer and one is output layer, and there are multiple neurons in each layer. After that, we move from single layer perceptron to multi-layer perceptron. So we saw that there are a number of problems which can be resolved by using multi-layer perceptrons, and it's a bit different from single layer perceptron. So what happens in multi-layer perceptron is that we have multiple layers. We have an input layer and an output layer, very similar to a single layer perceptron, but in addition to that we have also multiple hidden layers in between. So it depends on the problem or the input data set, that how many layers we want to have in our network. So normally there are two layers, or it can be one layer, or it can be more than two layers. So depending upon the problem and data set, we decide that how many layers we want to have in our network. So after discussing all this, we also discussed the learning mechanism of a perceptron and a multi-layer perceptron. We saw that we have feed-forward mechanism, and we can learn the weights through the feed-forward mechanism or the delta rule. So the ultimate target is to adjust the weights which are present on each connection between the neurons. So we discussed that the classification problem can be resolved if the weights of the network are adjusted properly. And as we are discussing the domain of supervised learning algorithm, so we have a target output, or a desired output you can say, and by using the target output or desired output, we basically trying to adjust the weights, and this adjustment of weights is called the training of the network. So today we will discuss another learning mechanism, which is backpropagation algorithm, which is used to train a neural network, which means that we will basically be adjusting the weights of the neural network through a backpropagation mechanism. So let's start, and let's dig a bit deeper in the backpropagation algorithm. This was basically proposed in 1969, and it is a generalization of the delta rule, which we basically discussed in last lecture. Backpropagation is a common method of training artificial neural networks used in conjunction with an optimization method such as gradient descent. So I explained gradient descent also in the in last lecture, and we saw that how we use this optimization method. So optimization method can be gradient descent, or it can be an advancement of gradient descent such as stochastic gradient descent, or normally nowadays we basically use ADAM optimizer in neural networks. So all these are the optimization techniques, and we use these techniques in conjunction with the backpropagation algorithm. So in backpropagation algorithm, we calculate the gradient of a loss function with respect to all the weights in the network. So the basic purpose of calculating the gradients of the loss function is that the gradient is basically fed to the optimization method, which is the gradient descent, and which in turn can be used to update the weights. And when we are updating the weights, this means that we are basically minimizing our loss function. So the target is to minimize the loss function and adjust the weights accordingly so that we have the fully adjusted weights, and then we can use those adjusted weights for the classification task. So the updation of these weights is an attempt to minimize the loss function. So loss function is basically calculated through the supervised learning domain in which we have the target or the desired output, which helps us to calculate this loss function. Okay, so we can use gradient descent to minimize the error. And what is this error? I also explained in last lecture. So let's repeat it. This error is basically the error which we have between the computed value of the network and the value of the target value or the desired value. So we have two values here. Okay, one value is being computed by the network, and what is that value? We have some input data set here, and we are passing those data sets through each layer, and our network is computing the values which we have here as an output response. So these are the output response values of the network. And then we have our target class, because you remember that in supervised learning domain we have a target class or a desired output, or I can say simply the labeling of the data. So what does it means that if I have a data set between of different clothes, and those clothes belongs to different brands, then I can say that each brand I can assign some numerical value to each brand. So let's suppose if I have 10 brands, then I can say that brand is 0 is, for example, this brand, and brand 1 is maybe another brand. So I have these desired values because I know that which category belongs to which brand. And then another value will be computed by the network, and when I will calculate the difference between the calculated value of the network and the desired value, I will have this error. So in gradient descent, the target is to minimize this error, because when we have the minimum error, it means that the values which are being computed by the network are very close to the desired output values. And this is our target. We want the network and the values of the network to be as close as possible to the desired value, because the desired value or the actual value is the correct value or the correct class. So our correct classification will be much better if we have this error being minimized as close as much as possible. So in order to minimize this error, we basically propagate deltas to adjust for errors. So these deltas are basically propagated back to the previous layers so that we can adjust these errors backward from outputs to hidden layers to inputs. So how this error propagates back? It first propagates from the output layer to these hidden layers, and then from hidden layers to these input layers. Okay, so we have basically two passes here. One is the forward pass and one is the backward pass. In the forward pass, we have these input patterns here, and we are moving these patterns or values into all the layers of the network, and after the forward pass we will have an output response of the network, right? When we have this output response of the network here, we also have another target class here, and then we will compute the difference between this output response and the target class. So as I calculate the difference, this difference will generate an error here, so which will be the difference between the two values. Then I will use this error in the backward pass, which is basically the back propagation, and I will pass this error back to the output layer, and then output layer to the hidden layer. And then if we have two hidden layers, then maybe we have another hidden layer here, and this error will be passed from this hidden layer to this hidden layer, and then finally to the input pattern. So this way in back propagation we have a forward pass and a backward pass. In forward pass we basically calculate the output response, and in the backward pass we basically propagate back the error of the output layer. Now let's discuss this mechanism one by one, step by step, so that we can have a much better a clear understanding of the backpropagation algorithm, because it is very, very important. And in most of the neural networks, we use backpropagation algorithm. Even the modern day deep networks also use backpropagation algorithms in order to adjust their weights.